All right. Okay, so let's try to make this brief. You guys can have homework time, right? Linear functions. I know I've pounded this down your throat, so it should be second nature by now. Okay, what's, let's say, slope-intercept form of an equation? You guys remember? Okay. What does M represent? Okay. Do you remember the slope formula?
y2 minus y1 over
Okay, good. And then B is the y-intercept. Okay, you guys are good there. I think we're okay with that. Do you know general form of a linear equation? Do you remember that? Or standard or general?
A2.
Pretty close.
A squared. AX.
There. AX plus BY equals C. You might see that a little bit more this year, but maybe not. Just keep it in your brains. Two ways to find slope here, right? Most of you probably solve for y. You can solve for y and get y equals, so you can use the top one. Or you can do this. If you remember that, you just plug it in and you're good to go. And then you can do the y-intercept as C over B. It's the same thing as solving for y. You just don't have to actually physically do the math if you remember those formulas. Okay. Do I need to show you a graphing example for either of those? Okay, I'm going to show you one that's a little bit harder. This is another way to graph. I think I've shown it to you, but it's very useful to know how to find X and Y intercepts because in real world problems they mean a lot. Can. Yep, that's one way to graph it. But I'm asking you to use the X and Y intercepts specifically. Does anybody know how to find the y-intercept here? Aha, put 0 in for x. Thank you, Kira. So this becomes nothing, right? The 2x becomes 0. So you get so what does y equal? Anybody?
3/4.
Close. Still just as close.
4/3.
Thank you. So subtract 4, divide by -3. So, and then the x-intercept, we put 0 in for. It's positive because you subtract 4 and get -4 divided by -3. Positive. So stuff like that I'm probably going to skim over this year. It's stuff that we want to have down. If I put 0 in for y, what does x equal? Bueno. Close. Is that right? Oh, how did I do that last year? There it is. Go ahead and graph those two, the x-intercept and the y-intercept. I will catch you, I promise. Okay, x-intercept. There it is. Yeah? No, it's not. It's just different than we've seen it. So x-intercept's -2, y-intercept 4/3. Done. Okay, another way to do it. And you know how to find x and y-intercepts now, right? What? Which one? This one? It's 4/3, which is 1 1/3. So on the y-axis, I go up 1 1/3. Gotcha. Look at example 2 in your book. It's on page 21, I believe. What can slope also be called? You bet. So if you're asked for rate of change, average rate of change, you're calculating slope. Okay, that's what example 2 is looking for. Yummy. Okay. Are we good? Moving on. Okay, types of slope. Do I need to go over positive, negative, 0, and undefined? 0 slope. I do want to address those actually, just in case. Be real quick here. So a horizontal line, remember, has a y equals a number equation. Does that ring a bell? Okay. And vertical line is x equals some number with an undefined slope. Why is the slope undefined? Not necessarily. When you calculate slope as a fraction, what happens? The change in, it's the y values over the x values. Why would that be undefined? There is a change in the y because we're changing the y. So it's dividing by 0. Okay, the x doesn't change, so we're dividing by 0. That's why it's undefined slope. Oh, that's a code word for change. It's the Greek letter delta. You learned epsilon earlier this week. Now you've learned delta. We're getting through the Greek alphabet here. Alpha, beta, etc. But it means change in. So anytime you see that, you can probably assume it. Okay, one terminology thing. You saw this last year. We related it to quadratics. What did a zero mean to find? What did we find when we wanted zeros or roots of a quadratic? Do you remember? So if you're asked to find the zeros of any function, linear, quadratic, cubic, it is find the x-intercepts. Think you can handle that on a linear function? Yeah? Because I already showed you an example. Okay. Good? That's it. That's today. So we spent a month on that in Math 3 and a week on that in Math 4, and now it's one day. Okay. Do you need me to write that down bigger? Again, there's some more word problems here, so. Check your odds. If you want some help on yesterday's work, please get it. You can get it today too. And if you want to bump your grade and finish it, you can finish it and I'll bump your grade, okay? It's up to you. I'll allow you to redo your homework as much as you want to get better grades. Okay? Because all it's going to do is make you a better math student. Yep.